Hello students, I am Sanjay Shirude, teacher in mathematics from Willingdon College, Sangli. In last lecture, we learned chapter Differentiation of Mathematics paper 2. We see the formulae, standard formulae and derivative of composite function and some examples on composite function. Today, we will continue the same with the PowerPoint presentation. Now, to see this example, tan of cos of sin x. Now, we denote the given function by y. So, y is equal to tan of cos of sin x. Now, by taking derivative of both sides with respect to x, we get dy by dx equal to d by dx of tan of cos of sin x. Now, that can be written as, see here, derivative of tan x is sec square x. So, derivative of tan of bracket is sec square of bracket into derivative of bracket. So, d by dx of cos of sin x. Now, here sec square of bracket as it is, derivative of cos of sin x is minus sin of sin x into d by dx of sin x by using chain rule. Now, dy by dx equal to, see here, derivative of sin x is a cos x. This minus sign remains the same. Now sin of sin x remains the same, and here sec square cos of sin x remains the same. Now this is our answer. Dy by dx equal to this. Now to continue, number 5, that is cot of log of x upon 2 minus log of cot x upon 2. Now again we denote it by y. So y equal to given function. By taking derivative of both sides, with respect to x, we get dy by dx equal to d by dx of right hand side, that is this. Now, derivative of cot x is a minus cosec square x. So, derivative of cot of bracket is minus cosec square of bracket into derivative of bracket. 1 upon 2 is constant, derivative of log x is 1 upon x. So, you write derivative of log x upon 2 is 1 upon twice x. Here, derivative of second term, minus sign remains the same. Derivative of log x, you know, that is 1 upon x. Instead of x, we consider bracket. So, derivative of log of bracket, that is 1 upon a bracket, that is 1 upon cot x upon 2. Now, denominator of denominator becomes numerator. So, you write 2 upon cot x into derivative of cot x is minus cosec square x. So, after simplification, see here, this a minus and this a minus. What do you say? Minus minus becomes plus. So you write 2 cosec square upon cot x as a first term because it is positive. And now this a minus remains the same. 1 upon 2x remains the same. Cosec square log x by 2 remains the same. Now this is our answer. Now to see our next example, log of under root 1 minus sin 2x upon 1 plus sin 2x. Here we denote given function by y. So you write we have y equal to log of bracket. But you know that 1 plus or minus sin 2x can be written as in this way. Now what is this? This is the value of 1. If x is any angle, x be any angle, then cos square x plus sin square is 1. So instead of 1, you write this bracket. Now by using double angle formula, sin 2x equal to 2 sin x cos x, you write here 2 cos x sin x. No problem. And now what is this? Now it becomes cos x plus or minus sin x whole square. Now you can verify this. See here, expansion of this bracket, that is square expansion, is cos square x, then square of second term, that is sin square x, plus or minus 2 into multiplication of these two terms, that is 2 into cos x sin x. So you write instead of this cos x plus minus sin x whole square. And now y becomes log of, see here, 1 minus sin 2x. 1 minus sin 2x equal to cos x minus sin x. If here the sign is negative, you consider the sign is negative here. So you write cos x minus sin x in numerator. In denominator, we write the value of 1 plus sin 2x. Now here the sign is positive, so here you consider positive sign. So cos x plus sin x, here you write cos x plus sin x bracket square. So we write directly here cos x minus sin x upon cos x plus sin x whole square. Now square root and square get cancelled. So what we get? Log of cos x minus sin x upon cos x plus sin x. Now our next step is, here we divide both the numerator as well as denominator by this first term, that is cos x. So cos x minus sin x upon cos x and cos x plus sin x upon cos x. That means divide each and every term of numerator and denominator by cos x. Then we get log of 1 minus tan x upon 1 plus tan x. See here, cos x upon cos x is 1. Sin x upon cos x is tan x. Same thing is here. Now, this is our previous step. Now, instead of this 1, you have to write tan pi by 4. Now, this tan x can be written as 1 into tan x. So, here you write in this way, this is 1 into tan x. Now, this 1 can be written as again tan of pi by 4. So, you know very well tan pi by 4, the value of tan pi by 4 is 1. So, you write instead of 1 tan pi by 4. You can write tan x equal to 1 into tan x. So, instead of 1, you write this. And now, what is this? This is the formula for tan a minus b. Here a is pi by 4 and b is x. Tan a minus b, tan a minus tan b upon 1 plus tan a tan b. So our next step is this, log of tan pi by 4 minus x. Now our next step is, by taking derivative of both sides with respect to x, we get dy by dx equal to d by dx of log of tan of pi by 4 minus x. Now you know very well derivative of log x is 1 upon x. So our next step is 1 upon, instead of x you consider this bracket tan of bracket. So you write 1 upon tan of bracket. See here, derivative of log of bracket is 1 upon tan of. Now instead of x you consider tan of pi by 4 minus x. So multiplying this derivative by the derivative of tan of pi by 4 minus x. You know very well derivative of tan x is sec square x. Instead of x you consider bracket. So you write sec square pi by 4 minus x, and now multiplying this by derivative of this bracket, derivative of constant, that is pi by 4 is 0, minus sign remains the same, derivative of x is 1. Now this is the derivative of this function. Now our next step is, see here, minus sign remains the same, sec square pi by 4 minus x remains the same in numerator, and here the denominator is tan pi by 4 minus x. And now this can be written as, now I can simplify this. See here, minus sec square means 1 upon cos square of bracket. Now this is our bracket. Now what is tan? That is sine upon cos. Sine of bracket upon cos of bracket. So one cos get cancelled. You know very well. And so you write in this way. Here you write 2. Multiplying numerator and denominator by 2. Now 2 times cos of bracket into sine of bracket by using double angle formula. That is sine 2 theta. Now you write here sine of 2 times bracket. In denominator we write this 1 upon sine becomes cosec of bracket. Now this is our bracket. See here, this is our bracket. So final answer is minus cosec of 2 times pi by 4 minus 2x. Now this is our answer. And now here we consider our next step. Next slide. See here, differentiation. Here in differentiation we will see composite function. Then you say that composite means function of function. Now we see the chain rule, that is dy by dx equal to dy by du into du by dx. And we see some examples. And now we are going to continue more examples from our exercise. Here differentiate the following with respect to x. Now here I take this example as the number 1. Y equal to bracket raised to 5. In bracket you see 2 into x to the power 3 by 2 minus 3 into x to the power 4 by 3 minus 5. Now differentiate both sides with respect to x. We get dy by dx equal to d by dx of right hand side. Now here you know very well derivative of x raised to n equal to n into x raised to n minus 1. Now this is our standard formula. And now we have to take derivative of every term, each term. See here. First we consider derivative of x raised to n, that is n into x raised to n minus 1. 5 into bracket raised to 4, 5 minus 1, that is 4. Now instead of x we consider this bracket, so multiplying it by derivative of bracket. And now we take derivative of every term here. See here. 5 as it is. Now this bracket raised to 4 as it is. Now derivative of first term 2 is constant. Derivative of x to the power 3 by 2, by using same formula you write 3 by 2 into x to the power 3 by 2 minus 1, that is half. So we write x to the power half. 3 is constant, can be taken out. Derivative of x to the power 4 by 3 can be written as x to the power 4 by 3 minus 1, and it becomes, what you say, that is 1 by 3. So we write x to the power 1 by 3. So 3 as it is. Now 4 by 3 into x to the power 1 by 3 minus 0. Because derivative of constant is 0, so here you may write minus 0. And now, here our next answer is dy by dx is, our next step is this, and that is the answer. 5 into bracket raised to 4 into, here 2 get cancelled, so 3 into x to the power half minus 4 into x to the power 1 by 3. Now this is our answer. Now we will continue the next example. Y equal to 3 upon 5 into cube root of 2x square minus 7x minus 5 raised to 5. Now this can be written as bracket raised to 5 by 3 in denominator. So we take in numerator and we write in this way. 3 upon 5 remains the same. Now bracket raised to 3 by 5 in denominator can be written in numerator as bracket to the power minus 5 by 3. Now by taking derivative of both sides, dy by dx equal to, here 3 by 5 is constant, can be taken out, and then derivative of bracket raised to minus 5 by 3. Again you know very well derivative of x raised to n, that is n into x raised to n minus 1. Now this is our formula. It's a standard formula. Our next step is, see here 3 by 5 remains the same. Now say this is x bracket raised to n. What is n? Minus 5 by 3. So minus 5 by 3 into bracket raised to minus 5 by 3 minus 1 into derivative of a bracket by using chain rule. Now this can be written as, see here 5 get cancelled, 3 get cancelled, so minus sign remains the same, bracket raised to, now by taking cross product, minus 1 into 3 minus 3, minus 5 minus 3 becomes minus 8, denominator is same, that is 3. And here 2 is constant, derivative of x square is 2x, so 2 into 2x, that is 4x. Here derivative of minus 7x, minus 7 is constant, can be taken out, derivative of x is 1. And what is the derivative of constant 5? That is 0. So you write here minus 0. And so this is our final answer. Minus 4x minus 7. Now take this term in denominator. This power becomes positive. So we get, this is the derivative of given function. Now this is our given function and its derivative is given by this step. Now this is our final answer. Now to see example number 3. Y equal to cot cube of log of x cube. Now y is equal to cot of log of x cube whole. See here, we know very well cos square theta can be written as cos theta bracket square. If you consider raised to 3, here you write bracket raised to 3. If you consider raised to 8, here you write raised to 8. Same thing is here, we write this. And now here we consider our next step as by taking derivative of both sides with respect to x, that is dy by dx equal to d by dx of right hand side, that is cot of log of x cube whole cube. But you know very well derivative of x raised to n equal to n into x raised to n minus 1. So our next step is 3 into bracket raised to 3 minus 1, that is 2 Instead of x, you write this bracket. So multiplying this by derivative of bracket, that is d by dx of cot of log of x cube by using chain rule. Now our next step is, you know very well derivative of cot x is minus cos x square x. So instead of x, you consider here log of x cube. So its derivative is minus cos x square log of x cube. So our next step is this, minus cos x square log of x cube. Instead of x, you consider log of x cube. So multiplying it by derivative of log of x cube by using chain rule. So our next step is, see here, this is our previous step. Our next step is derivative of log of x cube. You know derivative of log x is 1 upon x. So derivative of log of x cube is 1 upon x cube into derivative of x cube. Now what is derivative of x cube? That is 3x square. So see in our next step, that is 3x square. Now this part remains the same here. So you see here only, you observe this thing. Derivative of x cube is 3x square. Now x square get cancelled here. So we get 3 upon x here. 3 into 3, 9. So our next step becomes 9 upon x with a negative sign. And now cut off log of x cube as it is, bracket square as it is. And cos x square log of x cube remains the same. Now this is our final answer. Derivative of a given function is this. Now our next example is y equal to e to the power log x bracket square minus log of x square. Now see the difference between these two terms. This is the square of log x and this is log of x square. Now what do you think about this? Here base is e. So we write our next step as this, log x bracket square minus log of x square, because we know very well a to the power log of fx to the base a equal to f of x. Then you say that if this base and this base both are equal, see here, this base and this base both are equal, then you write directly answer is f of x. Here e, here log of base e. So both base are equal. So you write directly this answer. So we write this answer by using this formula. And now our next step is by taking derivative of both sides with respect to x. Now dy by dx equal to d by dx of right hand side, that is log x bracket square minus log of x square. Here we take d by dx of right hand side means this, derivative of first term minus derivative of second term. By using which rule? By using subtraction rule of differentiation or derivative. And now our next step is, see here, you know very well derivative of x raised to n is n into x raised to n minus 1. So derivative of log of bracket square equal to 2 into log x into derivative of log x by using chain rule. Same thing is here. Derivative of log x is 1 upon x. Derivative of log of x square is 1 upon x square into derivative of x square. Now, see here, derivative of log x is 1 upon x, so 2 log x upon x. Now minus 1 upon x square remains the same, and derivative of x square is twice x. So we get this, and you say this can be written as 2 log x upon x as it is. Now x get cancelled, so we get minus 2 upon x as the second term. Now this is our final answer. Derivative of given function is 2 log x upon x minus 2 upon x. Now we will continue our next example. Y equal to 1 plus 4x raised to 5 into 3 plus x minus x square raised to 8. By taking log of both sides, dy by dx equal to d by dx of these two terms. But here the sign between these two terms is multiplication. So say this is u, this is v. See here, we say this is u and this is v. That means d by dx of y, that is d by dx of u into v. Now you know derivative of u into v, that is the product rule. See here, first function u, second function v. Now first function into derivative of second plus second function into derivative of first, this is known as product rule. Now by using this formula, you write this step. See here, this is u. So u into derivative of v, that is this, plus a v into derivative of u, that is this. And now by using standard formula, first term as it is, here derivative of bracket raised to 8 means 8 into bracket raised to 8 minus 1, that is 7, into derivative of bracket. Same thing is here. See here, first term remains the same, into derivative of bracket raised to 5, that is 5 into bracket raised to 4 into derivative of bracket. Now what is our next step? Here I write the formula. You know, derivative of x raised to n is equal to n into x raised to n minus 1. By using this formula, we write this. Now, this is our previous step, and now we will see derivative of this bracket and derivative of this bracket. See our next step. First two terms remains the same. Now derivative of 3, that is constant, 0. Derivative of x is 1. Derivative of x square is 2x. Same thing is here. Derivative of 1 is 0. Derivative of 4 is constant, and derivative of x is 1. So we write our next step as, see here, 4 into 1 plus 4x bracket raised to 4 into 3 plus x minus x square raised to 7 is a common. Can be taken out. Now here, see, 4 into 1 plus 4x raised to 4. 1 plus 4x raised to 4 म्हणजे इथे एक शिल्लक राहील, तो आपण इथे लिहिला आहे. त्यानंतर 8 can be written as 4 into 2. 4 is common. So this 2 remains the same. Now 1 minus 2x remains the same here. Now in second term, see here, 4 is common, तो पुढे गेलाय. Bracket raised to 4 is common, and bracket raised to 7 is common. So we write only 5 into bracket here. This 5 remains the same and bracket remains the same. Now this is our next step. Now you see, what is our next step? 4 into bracket raised to 4, bracket raised to 7. Now into, in this rectangular bracket we write, see here, 2 into this, that is 2 minus 4x. See here, 2 into 1, that is 2. This 2 into this bracket, that is 2 minus 4x. Now 2 into 4x, that is 8x. 8x into bracket, that is 8x into 1, that is 8x. 8x into minus 2x, that is minus 16x square. So this is the multiplication of these two brackets up to this. Now 5 into bracket becomes this. 5 into 3, 15. 5 into x, 5x. 5 into minus x square, that is minus 5x square. You can simplify this. Now our next step is 4 into bracket raised to 4 into bracket raised to 7 into bracket. See here, 2 plus 15 becomes 17. Then minus 16x square minus 5x square, that is minus 21x square. Then 8x minus 4x becomes plus 4x. Plus a 5x, that is plus a 9x. Now this is our answer. Given function is a y and its derivative is this. Now we will see this example. Now this is very special example for you. Now here x is given in degrees. So first we have to convert x degrees into radians, then we can take its derivative. So we write degrees into radian by multiplying pi upon 180. So x degree can be written as pi into x upon 180 radian. Same thing in denominator. Now our next step is, now see this, x degree can be written as pi x upon 180 radian. You learn in 11th standard in angles and its measurements. Now differentiate with respect to x. What we get? dy by dx equal to d by dx of right hand side. Now d by dx of, this is our numerator, this is our denominator. Now see here, say this is u and this is v. d by dx of u upon v. Now You know very well, quotient rule is derivative of u upon v with respect to x is v into du by dx minus u into dv by dx upon v square. Now, say this numerator is u and this denominator is v. And now our next step is, see here. What is our next step? You read this, 1 minus sine of pi x upon 180 into d by dx of 1 plus sine of pi x upon 180. V square v square v, this is v, this is u. V square v into derivative of u minus u into derivative of v. Now we will continue with the same step here. And now our next step is this. See here, derivative of 1 is 0, 1 is constant, its derivative becomes 0. Now derivative of sine is cos. So derivative of sine of this, that is cos of this. Instead of x, you consider pi x upon 180. So multiplying the derivative of pi x upon 180. Here pi upon 180 is constant, can be taken out, derivative of x is 1. So here we multiplying by pi upon 180. Same thing is here. Derivative of sine is minus cos, angle is same, and into derivative of this angle, that is pi x upon 180. Pi upon 180 is constant, into derivative of x, that is 1. So you write directly pi upon 180. Now the next step is dy by dx equal to pi upon 180 from both the terms is common. Cos of pi x upon 180 is common. In bracket we write 1 minus sin pi x upon 180 plus 1 plus sin pi x upon 180. Sin pi x upon 180 get cancelled. Here we write 1 plus 1, that is 2. So our next step is this. Here we write this get cancelled. So 1 plus 1, that is 2. And now after simplification, what we say? See here, 2 upon 180 becomes 90. So pi upon 90. Cos of this upon 1 minus sin of this, angle is same. We write as it is. And so final answer is, now this is in degree measure and this is in radian measure. So answer is in degree measure. So multiplying this by 180 upon pi, we get this as a final answer. Students, we will stop here and we will continue in the next lecture. Students, we will stop here and we will continue in our next lecture. Thank you.